Okay, finally, for this week, let's look at this previous quiz question. Here, a game is described between two kids, Ali and Ahmed. They observe the cars passing through the street, and Ali earns a point when a black car passes, and Ahmed earns a point where a white car passes. The first to collect 3 points is going to win the game, and we are going to assume half of the cars in the city are black, half of the cars are white, and each passing car is independent. So this essentially states that any car passing through has one half probability of being black and one half probability of being white. Now we will define an outcome of the game. Now outcome here, it both refers to the outcomes of the random experiment as well as the game. The outcome of the game as the order of cars observed when the game is finished. For instance, black, white, black, black is an outcome where Ali wins because he has earned 3 points by observing 3 black cars. Okay, and this is the first one, and this is the final one, where at which point Ali wins. But on the other hand, white, black, white is not an outcome because the game is not finished yet. Ali is at 1 point and Ahmed is at 2 points now. It could be white, black, white, white with Ahmed winning, or white, black, white, black, white, again Ahmed winning, or it could be white, black, white, black, black, in which case Ali wins. Okay, and the question is, how many different outcomes are possible? Okay, so in this question, the first thing maybe we should recognize is the symmetry. Since black and white has the exact same probability, and in the outcomes, you see, let's say this outcome, black, white, black, black, if I invert it, black into white, white into black, white, black, white, white, it's another outcome, but Ahmed wins in this case. So for any outcome given, there is a corresponding inverse outcome in which the other kid wins the game. Therefore, let's consider first the outcomes where Ali wins. So it will be a prefix, but it should end in a black so that Ali reaches 3 first. Therefore, that means the final card to be observed before the game finishes should be black. And here, since Ali has reached 3 blacks at this point, I have to have observed 2 blacks already. But here, I can also have whites in between, right? So it could be 0 whites, or 1 white, or 2 whites, but it cannot be more than 2, because if I have 3 whites here already, the game would be finished before the 3rd black. Okay, so that's the case where I'm not considering here, because I'm just looking at the ones where Ali wins. Okay, so there are 3 scenarios in which Ali can win. That's 3-0, 3-1, 3-2. And since the final one is fixed, it has to be a black. This here is just 2 blacks here, just 2 blacks. And that I can have with just one combination. It's just 2 blacks. There's no choice. And in this one, here I have 3 observations, 3 cars, 2 blacks and 1 white. So that gives me 3 choose 1 options. So it could be like a white, black, black, or black, white, black, or black, black, white. So essentially out of 3 cars, I have to assign 2 of them to black and 1 to white. That's the reason we have 3 choose 1. And finally, with this scenario, I have here 2 blacks and 2 whites. That means I have to assign 2 of 4 cards as white and the remaining as black. And this is 3, and 4 choose 2 is 4 times 3 divided by 2, and that is 6. And in total, this gives me 10 outcomes in which Ali wins. Now, as we have observed, for each of these 10, there is an inverse outcome where Ahmed wins. So black, 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 you have white, white, white. Or black, white, white, black, black, you have white, black, black, white, white, right? So there is a one-to-one correspondence between them, and they have exact the same probabilities because black and white have the exact same probabilities. Therefore, since I have a total of 10 outcomes where Ali wins, I also have exactly 10 outcomes in which Ahmed wins. Therefore, the answer to part A is 20. There are 20 total outcomes. In 10 of them, Ali wins, and in 10 of them, Ahmed wins with equal probabilities. So that observation also answers part B, which is 1/2. What is the probability that Ali wins the game? Since black and white has the exact same probability, these corresponding outcomes have the same probabilities. Therefore, the probability that Ali or Ahmed wins this game is exactly 1/2.